Okay, this is going to show Sparx dust versus conventional skate sharpener dust. Okay, the Sparx machine has got a wheel that during its life, basically the diameter probably barely changes. It's going to be the same size, it's got some super abrasive on there. The dust from the skates, whether carbon steel or stainless, is basically going to be basically all metal. Very little is non-metal. Conventional machine, you've got a wheel. This is from a pulley-driven machine from before World War II. This is from an ice figure skating machine, worn-down wheel. This is from an SSM. The Wissota machine's got a wheel like this that's a thinner thinner thickness, but bigger in diameter. I think 7 inches. The Blade Master and other ones have a 1-inch bore and either a 7 or 8 inch. Also, the Easy Sharp machine's got 1-inch bore, I believe. But all these have got basically an abrasive that wears down. So here you can see a wheel that's got a certain diameter. Over its life, it gets smaller in diameter. So the dust that comes out that you collect goes in a vacuum cleaner. Collection bag is a combination of the metal plus what's left of the wheel. So if I pull all this aside, take a rare earth magnet here. This is super strong. Put it on the Sparx one. You're just going to get attraction to the metal. If you take it to the conventional one, this is rare earth, so really too strong. If you do this with the rare earth one and play around with it, you can actually separate the metal from the dust. And right there, just for a second, you can see the pink. And that's from primarily the Wissota wheel I've been using, where I collected this from. But if you play with the rare earth magnet, you can actually separate the dust from the old wheel and the metal. So it's kind of an interesting science fair project. You can demonstrate how you can separate. There's the pink that's on the top. Now, it was all mixed up a second ago, and just by me holding the rare earth magnet like on here, you want to make sure you put the magnet in a bag, because you're going to get it all over it. The only way you can really get it off is put some super tape on there, because it's going to get stuck on there. So I'm holding it like this, and there you can see on the bottom it's all pink. And that's the wheel from the Wissota. Over here is pretty much all ferrous material. That's the Sparx wheel. Sparx wheel is actually mounted by the inner hub here. This is just basically the nut that pulls this down, or the pulls it tight, but actually the spindle is referencing to the inner bore on here. So they're referencing to the cutting rim, if you want to call that. It's got the deposition on there. Most of the other wheels like this there's clearance on a wheel, and it clamps down, and you have paper, of course, on either side. This one, the paper's off. This one is so old, it's from before World War II, and it actually has a belt-driven unit on a unit that looks like it's older than a Wissota, in the sense that that was an old one from a company in Iowa. And it's got a unit here, the ball bearing unit's still good. It almost, I don't know if that's an automotive one. But for a cool science project, if you want to show how to separate the dust, that's really neat, that you can show how you can separate the metal particles from the abrasive particles. When you mix this in the bag, you can get it to it's all totally uniform, to where it's all uniform. Take a rare earth magnet, just play with it, and it'll separate. Sparx dust, conventional grinding wheel dust. wheel gets smaller in size, so you get, is a rough rule of thumb, I'm just pulling this out of there, it looks like you get half steel, half grinding wheel. I think on some of these other big wheels they say 200 pairs of skates, and take that with a grain of salt because it all depends on how bad the skates are. That's conventional steel. This is stainless, a little bit less magnetic depending on the type of stainless. Still pretty magnetic, so pretty much all the steel that comes off is going to get stuck to a magnet.